Today we are going to talk about a paper whose title is Bridging the Gap Between Training and Inference in Neural Machine Translation, or NMT. What we'll cover is a novel technique to improve training and inference in neural machine translation. About me, I'm Dhruvil, a full-time data scientist and an AI consultant with MarkTech Post. So, as encoder decoder architectures using neural networks have been popular in machine translation tasks, right? So what we have here is an encoder, which is usually an RNN based model or a transformer more recently, and a decoder, which assumes a similar architecture. And then we use the source language sentence as an input to predict the sentence in the target language. So, for example, English to French translation and so on. So, what we expect is that the encoder learns the representation of the source language in a way which can be used by the decoder to translate the source sentence into the translated version in the target language. So the training usually happens as in, let's say, if you want to do an English to French translation, and then you have a English sentence, I am a student. So each word is a time step, and which is used as an input in the encoder, and the encoder generates a representation of the source sentence, which is used by the decoder. And at each time step in the decoder generates the French version of the word. So the training happens in the following manner. The output sequence, which is generated by the decoder, is used to calculate the loss against the ground truth sentence. So the each word at every time step is compared. Each predicted word at every time step is compared to the ground truth word, and which is used to calculate loss. The problem is that the model penalizes the translation if it is not exactly the same as the ground truth. But this is not accurate because a translation can be correct and at the same time not be the exact same as the ground truth, which is uh, the same as saying each sentence can be written differently and can mean the same. So penalizing the decoder for a hard match is not a very good way to train the model. Also, while training, the model uses ground truth word as context to generate the predicted word for the next time step. And while inference, the model is asked to predict the entire sequence from scratch. I mean, at inference time, the output at a particular time step is used as an input at the next time step. While training, each time steps gets the ground truth context word. Hence, while making an inference, the probability distribution used to predict words is different from the ones used when training. Now, the paper proposes a technique to bridge this gap between training and inference. The proposed method says that instead of using, hard matching, let us select an oracle word from the predicted words and then sample those words as context input instead of using the ground truth word always. The approach uses two methods to select this oracle word. First is the word level approach, and second is the second sentence level approach. To use these oracle words, that is to predict the jth target word, we select the oracle word from the j-1 time step and sample from ground truth with probability p, or we use the oracle word with the complement probability, which is 1 minus p. So this, I mean, the dependence on the ground truth gradually decreases as the training goes forward, because as you train more, the model learns the language more, and the less you need to depend on the ground truth words. So the probability p decays with time as we train for more epochs. So In the word level oracle selection approach, we use the probability distribution generated at the previous time step, which is the j minus 1 time step, and pick the one with the highest probability. In sentence level approach, we use beam search to generate possible candidates for translation, and then we evaluate the blue score against the ground truth, and then we sample the oracle words from these candidates, I mean the best candidate.